All right, guys, I'm going to work through and explain each of these questions on our review really quick. Again, feel free to pause, rewind, fast forward, all that good stuff to whatever you need to make sure you understand how to do all these questions, okay? So the first question says, what are the different ways we know how to represent slope or how to find it? Okay, so I'm going to talk about representing slope really quick. So to represent slope, right, we know that we could write that as rate of change or constant rate of change, right? We can also think of it as the change in y divided by the change in x. And we didn't use this notation a lot, but anytime you see a triangle in science or math, that's like a delta in the Greek alphabet, and that means change in. So instead of writing change in y over change in x, you might see it written as delta y over delta x, and that just means the same thing, okay? We could also represent it as rise over run. And then as far as how to find slope, right, we can, of course, use the actual formula that finds the change in y over the change in x, right, by using the formula y2 minus y1 divided by x2 minus x1. Okay. All right, the next few graphs, we're just determining the slope. So really, you just need to find some points that are exactly on the line. All right, so I'm going to kind of zoom into this one. It looks like it's hitting this dot perfectly, and this corner perfectly, and maybe this corner perfectly. Now be really careful when you're reading the graph, right? Because this is a very zoomed in graph, right? Because when I go from here to here, I know it looks like I'm going down like 5, but I'm not, because I started at 2 and I'm ending up at 1, right? So I'm really just going down 1, which is negative 1. And then I'm going from negative 2 to 0. So I know I'm passing all these tick marks, right? But those are just, 0.2s, right? So I'm going right to, which is a positive movement, right? So that means our slope is negative 1 over 2, right? And again, I know it's got to be a negative slope. I feel like a broken record because I've said this a million times, right? Because this is a decreasing line. So before I even calculate the slope or look for it, I automatically know my answer has to be negative before I even start the problem. All right, moving on to this one. This is a horizontal line. So even if I pick some points, which you obviously don't have to do this, right? The slope is 0, right? But again, let's talk about why the slope is 0. Because let's say I want to go from this point to this point. Well, I didn't rise any, so my numerator is 0, but I did run 1. Well, what's 0 divided by 1? 0, right? And that's because it's a horizontal line, and all horizontal lines have a slope of 0 because there's no rise and they're all run. Okay? All right. This is a vertical line. Again, if you want to pick some points, you can. You don't have to. It should just be automatic. I know that the slope is undefined because for a vertical line, vertical lines are all rise. Oh, I'm rising 1, right, to get from one point to the next up here, but I'm not running ever. So, and I cannot divide by 0 in math, right? It's like the #1 law of mathematics, right? Division by 0 is undefined, right? And that is the slope of all vertical lines. And remember, vertical lines are the super weird ones, right? Because they're not functions. They fail the vertical line test. They are not functions. They have no existing slope because it's not even possible to find it, right? Because it's a vertical line, okay? All right, our last one here, it's an increasing line. So right away, I know my slope is positive. No mystery there. So I just need to be like, oh, okay, I'm going up 1 and over 1. Again, pay attention to the scale, right? So I'm going up 1 over 1. Those are both positive movements. So my slope is 1. Please always simplify your slope, right? I really don't want it written as 1 over 1. You can if you want to, but we always want to simplify. All right, find the slope of each line. This is just using our good old slope formula. I'm going to write it down right here. This is on your formula chart. we should not be missing any slope questions, right? You did this, you've been doing this since 7th grade, and you have a formula chart to help you remember it if you ever forget it, right? So no excuses to miss a slope formula question. The reason why most people miss slope questions is because they don't pay attention to the fact that there's a minus sign. And then if I plug a negative in behind a minus sign, it creates a double negative situation. So you just need to be really careful. So here we go. I'm doing a 3A here. So here we go. I'm going to start with my 15 and go this way. You don't have to go that direction if you don't want to, but you just have to make sure you go the same direction both times. So this is going to be negative 15 minus 3 in my numerator. I'll just go ahead and simplify that. Negative 15 minus 3 is negative 18. If you're still struggling with basic integer rules, please use your calculator, right? Please use your calculator. Negative 15 minus 3 is negative 18. Then when I subtract 10 minus negative 2, you're creating a double negative. The minus sign from the formula and the negative sign on the 2. That is a double negative situation. So this actually turns into one giant plus sign. I don't know why I just changed colors. Sorry. And of course, 10 plus 2 is 12. Or you can type in 10 minus negative 2 in your calculator. It's going to tell you it's 12. And then, of course, so this is my slope, but it's not reduced. Again, your calculator will help you with reducing if you need to. I can clearly divide both of these by 6 to reduce the fraction. So that's going to give me negative 3/2 equals my slope. Okay, and again, you should have an M equals on that because we should have no naked numbers floating around without the reader knowing what your fraction is actually talking about. All right, so let's try that one more time. All right, here we go. Y2 minus Y1. Sorry, I'm going to fix this line because it's crooked and it's going to bother me. All right, so negative 7 minus 0. And then negative 2 minus 9. And again, if you want to just type all that in your calculator as is in fraction mode, it'll reduce it and give you spit out the right answer for you. I'm just going to go ahead and do it by hand though. Negative 7 minus 0 is negative 7. And negative 2 minus 9 is negative 11. Now I cannot simplify 7/11ths, but I can simplify a negative divided by a negative, which gives me a positive answer. All right. So make sure you simplify your fraction, whether it's with signs or with numbers. Right. All right, that takes care of the first page. Sorry, hold on, give me one sec. Okay, sorry. All right, oops, sorry about that. Moving on. Okay, All right, so here we go. One more slope problem. So let's see. Same thing. Same slope formula. So 10 minus negative 6, which is a double negative, and two negatives back to back make a positive. Then I'm going to do negative 2 minus negative 2. Oh, another double negative. So that changes to a positive. So this gives me 16 divided by 0. If you're not going to remember that this is undefined, then please use your calculator. If you type in 16 divided by 0, it's going to say error, divide by 0, right? And that should jog your memory like, oh yeah, this is the undefined. Right? All right, always use your calculator if you need to. All right, on number 4, it says find the slope from a table. Okay, so again, there's two ways about this. If you want to, you can write some points, like just pick any 2 points from the table, like negative 5, 2 and 0, 6. And you can write them out like this. And then you're right back to the questions that we've been doing for the last 3 problems, right? That's not really how we want you to do the tables, but you can totally do that. Our intention is for you to find the change in y's, right? So I'm going to go find my change in y's. It looks like I'm adding 4 every time. So as far as slope goes, my numerator is a positive 4. because that's the change in y's. And then I go up here and find my change in x's. It looks like I'm adding 5 every time, adding 5, adding 5. So that's my change in my x's. So 4/5 is my slope, right? Because I can just simply analyze my table with that. So let me scooch that over a little bit. There we go. All right, let's go do another one of those. Let me change colors. I'll go with pink. All right, so here we go. Change in y's. Well, what's happening to our y's every time? 2 to 1. That looks like I'm subtracting 1. So that's my change in y's. And then I'm going to go to my numerator. -8 to -4. Looks like I'm adding 4. And you can see that that's happening all the way across. So my change in x's, which is my denominator, is 4. I know it's so tempting to put the 4 on top because x comes before y, but please remember, look at your formula chart, right? It's always change in y over change in x, right? So -1/4. All right, moving on. Find the value of x or y so that the line through the points has the given slope. So we've provided graphs here. I'm going to do it. Remember, we also learned how to solve this using a proportion. So I'm going to do one using a graph and one using a proportion, just to refresh your memory. If you wanted to solve them both by graphing, because that's definitely easier, then that's great, right? But if you want to step up your algebra game a little bit, then try solving it as a proportion by using the slope formula, okay? So here we go. I'm going to graph what I know. So the only point I know for sure is -3, -3. So I'm going to plot that point. And then I also know I have a slope of 1/3. Well, I can plot that because I have a point on my line, right? -3, -3. I just graphed it. So from there, I can apply my slope. Up 1/3, up 1/3, right? So I know that this is my line, right? And so I want to use this graph to my advantage and figure out what is the x value, right? What is the x value when y is -2? Okay, well, here's where y is -2. And isn't that the point, isn't that the point 0, -2? Okay, so what's my x value right there? 0. Right, and that's our answer. And guys, if you're not 100% sure, check your answer, right? Put it in to the coordinate 0, -2, -3, -3, and run yourself a little quick slope formula. You're going to get -1 over -3, which is +1/3, right? So you can always check your answer. It's not like you're just taking some wild guess and hoping that it's correct, okay? All right, on B, you can do the graphing method. That's totally fine, but I'm going to solve this one as a proportion. So remember, we're just going to use our slope formula, right? Again, I'm going to write that down. y2 minus y1 over x2 minus x1. And they've given us all of that. We just have to plug it in, right? So let's see. I'm going to use a highlighter. So my slope is -1/2. So I'm going to plug that in right there. So, oops, yikes. So -1/2. I'm going to give my negative to the 1. You can give your negative to the 2 if you want to. I always put my negatives with the numerator. Then I'm going to do y2 minus y1. Well, y2 is y, right? And y1 is 2, so I'm going to write y minus 2. And then my x2, whoops, is 4 minus -2. And 4 minus -2 is going to give me 6. Sorry. Again, 4, I just minus -2. Right, so I just went ahead and added since it's a double negative. And now I have this lovely proportion. Right? And how do we solve proportions? We cross multiply. Guys, you will have to do this again next year in geometry, right? You'll be asked to do these exact same problems. You will not be provided with graphs, right? They will totally expect you to be able to solve this using a proportion, right? And so that's why we kind of want to, practice doing the harder stuff. All right, let's see, I'm going to cross multiply. So let's see, I'm going to cross multiply this way first. It doesn't matter. -1 times 6 gives me -6, right? And then if I cross this way, let me pick a different color. Let's do purple. If I cross this way, I have to remember that 2 has to get multiplied by both the y and the 2, right? We have to distribute that multiplier. So that's going to give me 2y minus 4. And then I just have this nice cutie little two-stepper algebra equation to solve, right? And so I need to solve for y. So what am I going to do? I'm going to get rid of my subtractor of 4 by adding 4. All right, and that's going to give us -2 equals 2y. And then we're going to get rid of our 2 multiplier, so it becomes a 2 divider on the other side. So y equals -1. Okay. I know that's definitely harder and it's more work, right? But again, if you're just ready to kind of step up your algebra game, then that would be our expectation, right? That you would be able to do it that way. If you want to use the graph, that's totally fine. Let me just run through that really quick again as another example. The only point I know is -2, 2. So if I plot that, it's right here. And I know the slope is -1/2. So down 1, right 2, down 1, right 2, down 1, right 2, right? Or I could go up 1, left 2. So there's my line for sure. And they want us to figure out what is the y when x is 4. Well, I don't know. Let's go over here where x is 4, right? Which would be this line right here, which means this point is our winner, right? And that's the point for -1. Well, what's the y value there? -1. And notice that's exactly what we got here when we solved it. Okay, so graphing method or proportion, you will be provided with a graph on your test for this question, right? So it doesn't matter to me which method you use. Okay, just use what you're comfortable with. All right, let's hop up here. Being able to write equations. We're going to go ahead and write all the forms here really quick. This will not be on your test really because it's on your formula chart, right? We're just putting it on your review to make sure that you know all your forms. So slope-intercept is, of course, y equals mx plus b. And it's called slope-intercept because the m is the slope and the b is the y-intercept, right? Then we have point-slope form, which is y minus y1 equals m times x minus x1. And it's called point-slope form because the x1, y1 is one of the points on your line, typically not the y-intercept, right? Because the whole point of point-slope, here's your slope, by the way, the whole point of point-slope is a middleman to get to y equals mx plus b. That's literally the only reason why we use point-slope, okay? And then standard form is ax plus by equals c. No fractions, no negative starter, right? So remember your 2 rules there. It must have a positive ax term. I'm just going to write the little rules here. Right, the ax term has to be positive. I don't care if the b and the c are negative, just the ax cannot be negative. It must be positive. And then there's no fractions or decimals allowed in standard form. Right, so those are your 2 little rules that you have to remember. And then, of course, we have direct variation, which you can either write as y equals mx, or you can write it as y equals kx. Remember, sometimes they just change it to a k, which represents the constant of proportionality. And remember, direct variation equations always pass through the origin, which is why we don't have a b. We didn't write y equals mx plus b, because the b is literally always 0. So it's just mx or kx, whichever way you want to write that. All right, here we go. Given the equations below, write their slope, y-intercept, and point depending on which form the equation is in. All right, so clearly if it's in y equals mx plus b, you should be writing, you should be able to tell me what the slope and the y-intercept are. So this first one, clearly in y equals mx plus b. Now be really careful because we've seen this a dozen times, right? They wrote it as b plus mx. So if you want to write that above it, because clearly they put the constant first and then the x term last, it's the same thing, right? It doesn't matter what order we write our terms in. So clearly the b, oh, sorry, I meant to use a highlighter there. Clearly our y-intercept is -3. Please, for goodness sakes, I've said it 500 times, do not just write -3 for the y-intercept. I'm going to count it half wrong because you're missing half of the answer. Any intercept, it doesn't matter if it's an x-intercept or a y-intercept, is a point on the line. So your answer needs to be a point. 0, -3 is the y-intercept. And then, of course, the slope is the number in front of the x when it's in slope-intercept form, so +1/4. I'm going to erase this. Sorry, I'm going to kind of color code this so it's maybe a little easier to read. 0, -3. Okay. All right. B. Now, it might look not like it's not, but it is. He's written in mx plus b form, but you'll notice there is no x term, and the reason why is because the slope is 0. Right? There's no x term because there's a 0 multiplier in front of it, and that makes it redundant to write. Nobody's going to write that. Okay, so our slope is, sorry, I'm trying to keep the colors consistent. I keep messing it up. Right, our slope is 0, and our y-intercept is the +5, but of course we're going to write that as 0, +5. And just as a little reminder, what kind of line would that be? It would be a horizontal line because only horizontal lines have slopes of 0. All right, C and D, these are clearly in point slope form, right? So we can, if you need to write it above, you can. Now, more than likely, when you see point slope form, you're probably going, sorry, it's my dog, probably going to distribute and get it in y equals mx plus b form, but that's not what they're wanting you to do here. They're wanting you to actually pluck out the slope and the point from the point slope form. All right, so clearly our slope is nice and easy to find, right, because it's sitting right there as 2/5. All right, now you need to remember your x coordinate, right, is the number behind the x minus. Right, so your x coordinate, let me plug this, is just +4 because the minus is built into the formula. So this minus is not telling me I plugged in a -4, right? The minus is already built in, so I plugged a +4 in behind that. Okay, and I will write down, let me put a little comma. There we go. So remember, it's always the opposite of what you're seeing in the formula. Yes, I am seeing a -4, but that means it was a +4 that I put in for x sub 1. And then, let me find a different color. And then we have our y1 value, but notice it changed to a negative, which means this had to have been, let me write it underneath. The only way that could have changed to a plus sign is if I took the y minus and I put a -1 behind it, right? And so that is my y1 value is -1. Okay, remember it's the opposite, always the opposite of the number that you see right here. Okay. All right, let me just hold on. I'm going to throw in a reminder here. Guys, and this is only true for point slope form, that it's the opposite of what you see in the formula. Right? And so I see a -4, but that tells me that I plugged in a +4 behind the minus sign. Okay? All right, I'm not going to explain as much over here. It's the exact same thing on the next problem. Clearly my slope is -2. If you want to write that as -2/1, you're more than welcome to. It doesn't matter to me. And then, of course, our point is going to be -3 because it's the opposite of the x value, and then +5. Okay? All right, moving right along. Convert the following equations from their original form into the listed form. If you don't remember how to do this, on your day 4 homework, I put a whole explanation and examples of all the steps to go from every form and an example to look at. All right, so pull out your day 4 homework and look at all that stuff, all that conversion help that I put at the top. All right, so this one wants us to go into standard form, right? So remember, write it down. Right? I know it's on your formula chart, but just write it down so your eyeballs can see, oh yeah, standard form. That's the one where all my x's and y's have to be on the left and my constant needs to be on the right. Well, when I go up here, my y's are already on the left, but my x's are not. So I automatically know I need to take these minus 2/5 x's and I need to move them to the left to join the y. Again, I've said it so many times. If I pick up a minus 2/5 x or a negative 2/5 x from one side and move it to the other side of an equal sign, it must change sign, right? A subtractor on the right becomes an adder on the left. So this is now going to become positive 2/5 x. It can't be negative because he moved across the equal sign. And then this y is positive, so I'm going to make sure I write plus y. And then equals, and of course the only thing I have left over here is my constant of -4. And you'll notice it's just by moving the x term, it's totally starting to look like ax plus by equals c. The only problem is the rules, right? Standard form cannot start with a negative term. I'm clear there because that's a positive x term, so I'm good there. But I cannot have any fractions, which means I need to fix my fractions, which means I need to get rid of the divide by 5. And how do we get rid of a divide by 5? We multiply every term by 5. You can't just cherry pick which terms you want to multiply by 5. Everybody has to get it, or else you're changing the linear equation to some totally other different line. All right, now you can either type this in your calculator, 5 times 2/5, or you could recognize that we multiply to 5 with a divider of 5, and the whole point is that they cancel out. So that's going to leave us with 2x plus 5 times y, which is 5y, and then -4 times 5, which is -20. And that is our final answer, 2x plus 5y equals -20. Please show your work on your test. I try to give you as much partial credit as I possibly can. Some of you guys keep trying to do all the math in your head and you are making mistakes almost every time, right? Please show your work. And if you don't, if you just do it all in your head and you get it wrong, I have to take off the full points, right? If this problem was worth like 8 points on the test, I couldn't give you a single point because I can't follow any of your logic, right? So please show your steps so I can see what you're doing, okay? All right, here we go. Next up is slope-intercept form from standard form. Notice this is clearly standard form, but we want to get it in y equals mx plus b. So again, you need to take clues, right? What is it that makes y equals mx plus b special? Well, the y is all by itself. So I need to take this standard form and I need to get this y all by itself, which means I need to move this guy and this guy to the other side somehow. We've done this, again, dozens and dozens of times. We have to move the term that is not attached to the y first, which means we need to pick up this positive 5x and move him to the other side, right? But remember, you just can't pick up a positive 5x and move him to the other side and still be a positive 5x. Right, when I move him to the other side, he becomes a negative 5x. He has to change sign to go across the equal sign. And then I just literally bring down everything else. I'm going to bring down the negative 3y. Please don't forget the negative. He belongs to the 3y. You must bring him down. And then this positive 7, he's my constant. So I'm just going to kick him out to the side with the plus 7 over there. And you'll start to notice already this mx plus b happening, right? But we're not quite done because we still have to get this -3 multiplier off of the y. So what are we going to do? We're going to divide everybody by -3. Now, are these going to be friendly numbers? Absolutely not. But who cares? That's okay. You do need to clean it up a little bit. I cannot reduce 5/3. Again, that's your slope, so please leave it alone. It's a fraction, and he's good that way. I can't reduce 5/3, but I can simplify the negative divided by the negative. So this is going to turn into a positive 5/3. I'm going to kick the x out to the side. And then over here, that's also going to give me an infinite decimal, which I absolutely do not want. And please also don't give me a mixed number. Please don't write that as 2 1/3. We don't do that in high school anymore, right? So just leave it. But I do want to recognize that a positive divided by negative is going to result in a negative. So I'm just going to write this as -7/3. Okay, and that is going to be our answer. Y equals 5/3 minus 7/3. And just leave it. I know the numbers aren't pretty, but that's okay. All right, last but not least is clearly a point slope equation, right? Y minus y1 equals mx minus x1. And they want us to put it into slope intercept form first, it looks like. This is a double question, right? So the first thing they want us to do is take it into y equals mx plus b. Well, that's great because that's pretty easy from point slope form. Again, the defining characteristic of point slope form is that the y is all by itself. Well, I'm going to go up here. Where's my y? Oh, it's right here. I need to get him all by himself. But not only that, y equals mx plus b does not have parentheses. So I also need to get rid of the parentheses. And that's what we actually want to do first. Okay, so let me go find a better color here. I like this turquoise. Okay, so the first thing we need to do is we need to distribute, which means to multiply. Please make sure you are multiplying and you're doing it to both terms. Some of you guys just keep bringing the -4 down as if you draw the arrow, right? You draw the arrow to show that you have to take the -2/5 times the -4, but you don't actually do it. So please make sure, right, that you're actually multiplying. Just use your calculator if you need to. All right, so here we go. -2/5 times x is just -2/5 x. And then it's a -2/5 times a -4. Again, type it in your calculator if you need to, right? But that's a negative times a negative, which makes it a positive. And 2/5 times 4 is going to give me 8/5. Again, is that friendly? No, but it's okay. And you have a calculator to use, so no biggie. And I'm just going to bring down my y plus 1. So as soon as we distribute, we can start seeing that mx plus b take shape. The only thing we need to do is get this 1 adder off of the y and subtract it over here. And again, if you don't know how to work with fractions, please don't assume that you do, right? Use your calculator to double check your math, even if you think you know what you're doing. Because in order to subtract and add fractions, you have to have a common denominator, right? So when I type this in my calculator, 8/5 minus 1, right? That's going to give me 3/5. Okay. All right, and that's my answer for slope intercept form. Y equals -2/5 x plus 3/5. Now, if you want to pause the video for a second and try to do the standard form by yourself, that would be an awesome idea, right? And then see if you can get the right answer from there, right? If you don't want to, that's okay. All right, so we now need to get it into standard form. Okay, so I'm going to kind of draw a little line here. All right, so standard form, remember, again, I always like to write it out just so visually I can kind of prepare myself. AX plus BY equals C. So remember the X and the Y terms both have to be on the left-hand side. Okay, well, I'm going to copy and paste this so I'm not writing over my answer. There we go. So I'm going to start here, and I need to get all my x's over to the other side. So I'm going to take this negative 2x or minus 2x. He's technically a subtractor. And I'm going to bring him over here. But remember, I just can't put a negative 2/5 x on the other side. If I hop over an equal sign, my term has to change sign. So he's going to become a positive 2/5 x when I move him to the other side. And then, of course, my y is positive, and my 3/5 is positive. That's left over there. Well, the cool thing is my x term is positive, so I'm not breaking that rule, but I do have a 5 divider. I've got 2 of them, actually. Oh, sorry. Right, I need to get rid of these divide by 5s, and the only way to undo division by 5 is to multiply by 5. But everybody has to get it. And again, use your calculator if you need to, but these 5s cancel out because one's a multiplier and one's a divider. That's literally the whole point. So we get 2x, 5 times y is plus 5y, and then equals, and then of course the canceling is happening over here as well, right? And so that's just going to give us 3. Again, if you struggle with that, use your calculator, right? Just type in 3/5 times 5, and it'll tell you that it's 3. Okay, so 2x plus 5y equals 3. Okay. All right, hopping back to the top of the page. Now we're going to graph equations, right? We just wrote equations for the last like 15 minutes. So now let's actually graph the equations. When I graph an equation, I'm going to take everything to y equals mx plus b form. I don't care what form it's in. Everybody's going into y equals mx plus b. Now this one's already in y equals mx plus b form, which is awesome, right? So notice my slope is negative, right? That's my slope, negative 4/3. What do I know about my line if my slope is negative? And I'm just going to make a little mental note here on my paper. When I'm all done, I better be looking at a decreasing line because negative slopes mean decreasing lines, right? And then, of course, my y-intercept is positive 2. And you always graph your y-intercept first. Remember, this is your y-axis, so it's going to cross my y-axis at positive 2. So there's my first dot. And then a slope of negative 4/3. Please remember, the negative goes only with the top number. This 3 down here is a positive. Okay, negative 4 over positive 3. So we're going down 4, 1, 2, 3, 4, but then right 3, 1, 2, 3. And this is where we land. And that is our line. Okay, and it's decreasing. Yay. All right, let's go look at B. B is, sorry, I'm hopping around. Never mind. Okay, B is also in y equals mx plus b form. So let me try to use the same colors. So now my slope is a positive 2/5. What kind of line should I expect if my slope is positive? That would be an increasing line, right? So I'm just going to write that down so I don't forget. And then, of course, my y-intercept is negative 2. Okay, so that means I'm going to start at negative 2 on my y-axis. Again, here's my y-axis. And then my slope, everybody's positive, so all my movement is positive. So we're going to rise 2, 1, 2, and we're going to run 5. 1, 2, 3, 4, 5 to the right. And there is my lovely line. It is increasing, so I'm feeling pretty good about that. Voila. All right, let's hop to the next page. Lots of graphing. This whole page is graphing, right? So let's look at C. All right, so C is kind of standard form. It's breaking the rule with the negative starter, but overall it's in that format, right? I'm gonna change this into y equals mx plus b form. So remember, y equals mx plus b means I'm getting y by itself. Here's my y right here. So I need to get that y all by itself, which means I need to move the negative 2x to the other side, And I need to get my 4 divider off of my y by moving that to the other side. And it's the same 2 steps every single time, right? So hold on, I'm going to scooch this up a little bit. Okay, so I'm going to take a minus 2x or a negative 2x, and I'm going to move it to the other side, in which case, I'm sorry, he's going to become a positive 2x when I move him over there. He has to change sign. And then I'm just going to bring down everything I have left. My positive 4y is still over there. And then I'm going to take my little positive 8 and I'm going to kick him out to the side. There's my mx plus b starting to take shape right there. And then my very last step is to get rid of the 4 multiplier, and everybody gets divided by 4. So hopefully you can see that leaves us with y equals. Now guys, please, again, use your calculator if you need to. 2 divided by 4 and 4 divided by 2 are not the same thing, right? 2/4 reduces to 1/2. And then I'm going to kick my x out to the side. And then 8 divided by 4, that's 2. So here's our linear equation in y equals mx plus b form. And now we're right back to our other graphs, right? We love graphing in y equals mx plus b form. But if we can't get it in that form, then we're in trouble, right? It's like literally the #1 skill of an Algebra 1 student is being able to convert things into slope-intercept form. Again, my slope is positive. So what does that mean? Increasing lines. Again, write it down on your test just as a little checkpoint so you don't forget, like, okay, I already know the line has to be increasing because the slope is positive. And then after you graph your line, just do a quick double check. Like, is that what I'm looking at? Am I looking at an increasing line? It's totally worth it. And of course, our y-intercept is a positive 2. So it's crossing our y-axis at positive 2. And then our rise over run, we're rising 1 and running 2. So up 1, right 2. And voila, there's our graph. And you can draw more points if you want to. I am keeping it accurate by kind of doing that in my head and moving. But you can put as many dots as you need to. All right, scrolling down. Oh, looks like we have a point slope form, right? This one looks a little awkward. Notice it doesn't actually have a number right here in front of the parentheses, but it does. Remember, every parentheses has a number in front of it. There is an understood 1. So when I distribute, now could I graph it from this form? Yes, but most students that try to, they mess it up because they don't get the signs right on their point. So if you want to graph it right now, just hop right to your graph and graph it from point slope form. I love it all day long. Go ahead and do that, right? But if you're not confident in your graphing from point slope form, then just go ahead and convert it into slope intercept form by distributing the 1, which of course isn't going to change anything. It just allows me to drop the parentheses. And then I'm going to bring everything else down. And then we're so close, right? I just need to move this +2 adder, and he becomes a -2 subtractor on the other side. So y equals x. And guys, don't mess this up. Use your calculator. -3 minus 2. That is my -5. Okay. And so that means that my slope is 1 or 1/1. You know I'm going to say it. That's a positive slope. So I should be expecting an increasing line, right, when it's all said and done. And then, of course, my y-intercept is this -5. All right, so -5, 1, 2, 3, 4, -5, way down here at the bottom. But it's a slope of 1, which means up 1 over 1. If you want to keep going, awesome. Up 1 over 1, up 1 over 1, up 1 over 1. I'm just going to kind of make sure I'm accurate with that on my graph. Right, and there's our line. Yay. All right. Go back to the top. Let's do it all again. This guy is also in point slope form. So once again, if you're confident in your skills to pluck out the slope and the point and hop right to your graph, do it. Right? Love it. right? But if you're not super confident in that, then just take everything to y equals mx plus b form like we've been doing. Now this one's not going to be super friendly numbers, so this would be a case where I would actually kind of argue for point slope form, which we can talk about that here in just 1 second. I'm just going to go ahead and convert it to y equals mx plus b, which again is the same 2 steps every single time, right? So we're going to distribute the 1/3. So that's going to give me 1/3 x plus, and then 1/3 times 1 gives me another 1/3. Do not just bring down the plus 1. You cannot do that. You must distribute and multiply everybody inside the parentheses by the 1/3. And then I'm almost done. I just have to move this minus 3 and add 3. Okay, so that's going to give me y equals 1/3 x plus, now again, please use your calculator if you don't know what a third plus 3 is, right? That's actually 4/3 or 1 1/3. Now this is not going to be uber friendly to graph from this position. You can totally give it a shot. I'm going to go ahead and do that, but we'll talk about the point slope perspective in just a second. So 4/3 is 1 1/3. So that means my y-intercept is like here-ish, right? And then my slope is telling me to go up 1 full, which would put me here, and then over 3. 1, 2, 3. So this is going to be my landing spot right there if I go up 1 full unit and right 3 full units. Okay, and I'm just going to kind of, wait, hold on a second. I'm sorry. Wait a second. Oh, hold on. Did I mess up my math here? Just double checking my math. Give me 1 sec. Okay. Sorry. Let me double check my math really quick. Negative 1/3 x plus 1/3. And then we added, that is a y minus 3. Okay. So we wanted to add a third. So 3 1/3. Oh my gosh. Can I do basic math, you guys? Forgive me. It's so late at night. Okay. I'm so sorry. So, that's 9/3. I don't even know what I'm doing. So this is 10/3. Yikes. Oof. Okay. I was like, something is amiss here. Sorry. That's my fault. So it should be 10/3. I should take my own advice and use a calculator. I accidentally I did 1 plus a third, sorry, instead of 3 plus a third. Okay, that makes a lot more sense. Okay, so now my y-intercept, let me refresh here. So my y-intercept is the 10/3, which is 3 1/3. Okay, so I'm going to go up 3 1/3. So I should be here, right? And then my slope is 1/3. So I'm going to go up 1 full unit and then over 3. So I'm going to land here. Okay, oh, that looks so much better. All right, and then I can draw my line, right? So it's going to look something like this. All right, now, in my opinion, this is kind of a gross problem to convert into y equals mx plus b form. And I know it because of that 1/3. I'm distributing a 1/3, and this is not a nice multiplier times 1/3. So it just makes more and more fractions. And I really don't want to create more fractions. So if you want to graph this from point slope form, you can do what we were doing. Let me go back. Remember right here? When we talked about when it's in point slope form, we should just be able to pluck out the slope and the point on the line that it's referring to. That's how I would probably do this one. It would be a lot easier. So clearly our slope is 1/3 and the point they're giving us is -1. Remember, it's the opposite of what you're seeing right here, and +3. Well, those are a lot friendlier numbers to graph than all this 1/3, 10/3 business. So if I go to my graph, look what happens. Oh my goodness. Hold on. There we go. Do you see that my line has to go through the point negative 1, 3? Well, let's graph that. Oh, here it is. My line does go through negative 1, 3. And then it has a slope of 1/3. Up 1 over 3. Oh, look, it's going through that point too, right? So I get the exact same line regardless of whether I convert it to y equals mx plus b or if I use point slope form and just identify the point and the slope, okay? Obviously, this one is a million times easier, right? So I would opt to do it that way. All right, one more of these, I think. All right, so here we go. So do y'all want to do it the quick, easy way? We're going to do it the quick way because if I distribute 2/3, is 4 a nice multiplier to 2/3? No, it's going to give me 8/3. That's even worse, right? So I went from an equation that has one fraction in it to an equation that has two fractions in it. Let's not make things hard on ourselves, right? So I notice it's in point slope form. So I'm going to go ahead and pull out the slope of negative 2/3. And then I can go ahead and pull out the point, which is going to be the opposite of negative 4. So 4, and the opposite of positive 1, which is negative 1. It's going to bug me that that's crooked, so let me fix that. And then I can just plot those two pieces of information. Oh, it goes through 4, negative 1. That's this point right here, right? And it has a slope of negative 2/3. That means it goes down to over 3. Now, I know that goes off the graph. Don't freak out about that. If you want to go off the graph a little bit, you can. But remember, we can also get the points on the opposite side by doing the opposite movement. So instead of going down to right 3, we could go up to left 3, right? And get those points that lie on the opposite side for a nice, pretty graph. So I don't actually have to go off the graph if I don't want to. Notice my line is decreasing because my slope was negative, right? All things we should be checking. Oof, all right, that was a lot of graphing. Now let's go do some story problems. Here we go. Morgan wants to buy some items from the store. She knows she needs to buy 1 carton of milk for $2.36, but she also needs to buy some pears, which are 75 cents each. Write an equation that represents this situation in slope-intercept form. All right. So they're asking you for slope-intercept form. So I would assume that they're giving me a slope and a y-intercept. Notice I have to make that assumption because we're talking about the total amount of money, which is your y, right? So y equals, remember to find our slope, we want to look for that word each, right? So it's 75 per pair. Right, so 0.75x. Now, I know this doesn't seem like it, but it says she only wants to buy She only wants to buy 1 carton of milk. So there is no slope there because I know it's $2.30 per carton of milk, but she only wants 1 of them, right? So that's actually our y-intercept because she's only buying 1. So that's kind of like her starting price. Like she knows she's going into the store and spending $2.30 on that 1 carton of milk, but then she is spending more money, 75 cents each per pair, right? So I know that's kind of awkwardly written there, but that's how that's going to work. Okay. I'm going to scooch you this up a little bit. And I'm actually going to write down what our x and y variables are, right? So clearly x is the number of pairs that she can afford to buy or that she's going to buy. And then y is going to equal total money. Okay. All right, so now that we know the story problem or the equation, we can answer any question that we want by manipulating this equation, right? We've been doing this for the last couple of days, right? And so we should be pretty decent at this, right? It says, how much would her total be? Okay, well, total is which variable? Y. If she bought 6 pairs. Oh, well, they're actually giving me the number 6, and I know pairs is x, so that means wherever we see, I'm going to copy and paste this equation here. There we go, copy, paste. Let me shrink it down a little bit, right? So I know in my equation over here, I'm going to plug in the x value into the x equation, right? And so I can rewrite this equation, y equals 0.75 times 6 pairs, plus I don't want to forget about that 1 carton of milk for $2.30. Right? And then you can just basically use your calculator and you can type that in. 0.75 times 6 plus $2.30. And that gives me a y value of $6.80. And please put dollars on it, right? Because we don't want any naked numbers. We want our reader to know what the y is talking about, right? And y is total money, so put dollars on there. All right, on the flip side of that, and this one is definitely harder. Hold on. Sorry, I'm going to go copy and paste that equation again really quick. All right, so here's that equation that we wrote down. This is the one we're going to manipulate. It says, well, how many pairs? Okay, so now we're looking for x would she have purchased if her total was $13, and not 100, that would be a lot of pairs, $13.55. Well, that's money, and that's y. So this is asking us to take the y value and plug it in to our equation. Now, this takes a lot more effort because now you actually have to solve an equation, right? But I'm going to rewrite this as 1355 equals 0.75x plus $2.30. And then you need to solve the equation for x. This is just a basic two-step algebra equation. We should all be able to do this. I need to get the x by itself. So I need to move the term that's not attached to the x first. So I'm going to move this $2.30 adder, and he's going to become a $2.30 subtractor on that side. Sorry, I ran out of room, so I'm going to kind of mosey on over here if that's okay with everybody. So $13.55 minus $2.30, that's going to give us $11.25 equals 0.75x. So then all we need to do is get rid of that 0.75 multiplier by dividing the other side, and that's going to give us 15 pairs. Again, label your answer. Story problems should always have labels. Woof. Okay, here we go. Next one. One morning, James woke up and the temperature was 62 degrees at 8:30 a.m. Each hour, the temperature would raise 5 degrees Fahrenheit. Okay, well, he woke up at 8:30 a.m. and this was his, we're going to call that his starting temperature, even though I know it wasn't like at midnight or whatever, right? And so this is, because this was his starting temperature, because it's the first temperature he felt that day, right? So that's going to be his y-intercept. And then, of course, each hour, there's that key phrase, each, every, of, per, each hour, the temperature raises 5 degrees, right? So that means our slope, right, is 5 degrees per hour. So if we want to write that equation, y equals 5x plus 62. And again, I know my slope is positive because the word raise, right? If it said the temperature was dropping 5 degrees, then I would make it negative, right? Now this one's kind of tricky because it says, what would the temperature be at 1:30 p.m.? Oh, hold on. I got a little ahead of myself. Let's go ahead and write down what those x's and y's are really quick, just like we did with the pairs, right? So in this case, x is, right, time, right? It's going to be hours. Remember, x is always time. And y is going to be degrees Fahrenheit. Okay. All right, so now that we have our lovely equation, we can manipulate it. And, oh, that's so not what I meant to do. Sorry about that. Copy, paste. All right, I'm going to bring this down here. All right, So it says, what would the temperature be at 1:30 p.m.? Well, you got to do a little bit of thinking here, because at 1:30 p.m., I don't want to type in 1:30. I can't put an actual clock time in an equation. That doesn't make any sense. But I do want to figure out how many hours have passed. Okay, so I'm going to use that 1:30, right? And how many hours is that, right? So 8:30 to 1:30, what is that? 3.5 plus 1.5, so 5 hours. Okay, and so that's what's going to be plugged in for our x variable, because x is time. So we're going to plug a 5 in for x. Okay, so here we go. Let's take that, plug it in for our x right here. Right, so that's going to give us y equals 5 times 5 hours passing plus 62 degrees, which is going to give us 72. 72 what? Degrees Fahrenheit. And there we have it. All right. Man, this review is long. Okay. We're only at question 12. Okay. There's so many parts. All right, so here we go. Question number 12. Write the equation, oh my gosh, in all 3 forms. Awesome. Okay, well, clearly if I have 2 points, I have to find slope first. I don't have a choice, right? So because slope intercept and point slope both require slope. So here we go. We've already done this. This is kind of just putting everything together that we've been doing this entire time. So 3 minus negative 5. Again, we've got a double negative situation going on, so that actually changes to a plus sign, which gives us 8. And then 0 minus negative 2. Again, double negative, so that changes to a 2. And then 8 divided by 2 is 4. Okay, so our slope is 4. All right, now here's the really awesome thing. I need, well, it doesn't really matter. I'm just going to go ahead and recognize. Y'all notice anything special about this point right here? If you do, it's going to save you a little time and energy, right? Because 0, 3 is a y-intercept. Well, if I have my slope and my y-intercept, awesome. I can just go ahead down here and write my slope-intercept form, right? Y equals mx plus b, so 4x plus 3. If you don't see that, that's okay. You're just going to go through point slope form and then convert it into slope intercept form, and you're going to get the exact same thing. Now, point slope form, remember point slope form is y minus y1 equals m times x minus x1. Again, write it out if you need to. It's right there on your formula chart. I've already written a million times, so I'm not going to write it down again. So y minus, now you can pick either one of these points. I don't care. So if you want to pick the first point, then that's going to be a double negative. So this would change it to y plus 5 equals m times x minus negative 2, which would change it to a plus 2. Or if you want to use the other point, y minus 3 equals 4 times x minus 0. It does not matter which one of those you give me for point slope form, because the really awesome thing is that it's just going to convert into the same slope intercept form, so it doesn't matter to me which one you use. Now, what we need to do, though, is we still need standard form. So I'm going to copy this guy. Okay. Hold on. Put a little line up here. Okay. I'm going to take my standard, or my slope intercept form, and I'm going to use it to convert into my standard form. Oh my gosh. Sorry. Colors everywhere. All right, so remember, standard form is ax plus by equals c. It's the same 2 steps. I need to pick up a positive 4x, and I need to move it over here to join my y. But again, I just can't pick it up and move it. If I do that, the only way to move a plus 4x is to minus it to this side. So it's going to become a negative 4x when I move it to the other side. Then plus y equals 3. Now, pretty cool that this is almost in perfect standard format. I don't have any fractions, but I do have this negative starter, which I'm not supposed to have. So the easiest way to get rid of a negative starter is to multiply everybody by -1. Or you can divide everybody by -1, but I'm just going to go ahead and multiply everybody by a -1. It's the same effect. Well, a negative times a negative is a positive, and that's what gives me positive 4x. But then my y is a negative y, and my 3 is a -3. Right? And so that's going to be my standard form. 4x minus y equals -3. 4x minus y equals -3. Oh my goodness. Okay, one more of those. Okay, so again, 2 points. So we have to do slope formula. So here we go. Slope formula. y2 minus y1. Again, it doesn't matter which one you start with. So -2 minus -4. That is a double negative, so it's going to change to a plus sign. And -2 plus 4 is 2. Then we do 0 minus 6, which is -6. So 2 divided by -6 is -1/3. Please don't write -3, right? It doesn't say 6 divided by 2. It says 2 divided by 6, right? So it's a -1/3. Now, again, this one's pretty friendly because if you happen to catch, oh, 0, -2, that's a y-intercept, right? Who doesn't love it when you're given the y-intercept, right? So if you want, I can automatically just go ahead and hop down to my slope-intercept and just write that in. Y equals -1/3 x, and then my y-intercept is a -2. If you don't want to do that, or if you don't catch it, no big deal, right? Because my point slope form is literally just taking one of the points. It does not matter which one. If I use the first point, then my point slope form is y plus 4 equals -1/3 times x minus 6. Or if you use the second point, it would be y minus -2, which is a plus 2, equals -1/3 x minus 0. I would take either one of those answers. They're both correct. And if you need to, you can distribute and move the 2 over, and you're going to get that slope-intercept form. So if you don't catch it, you'll be able to get it easily anyway. All right, then I'm going to use my handy-dandy points or slope-intercept form that I found right here. Let me copy and paste it up here. Right? Oh my goodness. What just happened? There we go. Okay. So standard form is the same 2 steps. I need to get my x term to the other side. But he's a -1/3 x or a -1/3 x. So when I move him over here, he changes sign and becomes positive. And then I'm going to bring down my plus y. And my -2. Don't forget that he's a -2. Don't forget to bring that minus sign down. And my x term is positive, which is cool, but it has a fraction, and that's not cool. So I need to get rid of my divide by 3 by multiplying everybody by 3. And of course, 3 times a third is just 1. Use your calculator if you don't know this. So that's just going to give me 1x, or x. If you want to put the 1, you can. It's understood. And then 3 times y is 3y, and 3 times -2 is -6. Okay, so x plus 3y equals -6. Oof. All right. Here we go. Oh my goodness gracious. Seriously. Okay, do it all again from a table, right? So again, we need to find the slope. I'm going to go ahead and just analyze my table. We've done all of this before on this review, so I'm going to go through this pretty quickly. So 14 to 5 looks like we subtracted 9. So that's my numerator, change in y's, -9. And then over here from -6 to 3, looks like we added 3. And this gives me a slope of -3. Now, do y'all see anything special about any of the points in the table? I do. All right, looks like that one is a y-intercept. Yay! Right? So the y-intercept is -4, which means I can hop right to slope-intercept form if I catch that. If not, no big deal. But I did, so I'm going to go ahead and write that in. So y equals -3x minus 4. Now, point slope form, I'm not going to, guys, there's 4 different point slopes. There's 4 different points, so 4 different point slopes that you could possibly write. I don't care which one you pick. I'm just going to pick the first point just for absolutely no reason other than it's the first point, right? And so I'm going to use that to do my point slope form. So y minus y1 equals my slope of -3 times x minus -6, which is a double negative, so plus 6. Again, any of the points would work. I would accept them all, so pick one. It doesn't matter. Okay, now standard form, I'm going to do what I've been doing this entire time. So I'm going to copy and paste, so I have it up here. Right, the only thing I have to do to get it in standard form is pick up my x term and move it to the other side. Oops, sorry, using the inverse operation. Well, he's a subtractor, right? That's a minus 3x. So when I move him over here, he becomes a positive 3x. And then I just bring everything down. And awesome. I have a positive starter, which is what I need, and I have no fractions. So I'm done. Moving the x term is all I needed to do. So that's my final standard form. All right, doing it again. Here we go. I need to find my slope. All right, change in y's. Let me scooch that down. There you go. All right, change in y's. Let's see, -6 to 4. Looks like I'm adding 2. So that's a 2 in my numerator. And then for my x's, looks like we're adding 4. If you don't see that as add 4 right there, then go over here and do the 1 and 5. Go to the positive numbers, right? It's a lot clearer that that's +4 if you get lost on that. So that means my change in x's is a 4. So my slope is 2/4, which of course reduces to 1/2. So that is our slope. Now, unfortunately, do you guys notice how none of these points are our y-intercept? Because y-intercepts have an x value of 0, right? And none of these say 0. So none of these are my y-intercept. I do see a 0 right here, but that's an x-intercept, not a y-intercept. So that is of no use to me. So I am not going to be able to just hop right to my slope-intercept form equation on this one. Okay? So I need to pick a point. I don't care which one you pick. I'm going to just choose this one for no reason whatsoever. I'm just randomly picking it. So now I'm going to use my slope and my point, and I'm going to do point slope form. So y minus -2, right, because that's my y coordinate, which is a plus sign, equals 1/2 times, and my x value is 1, so x minus 1. And that's it. I'm done with point slope form. Y plus 2 equals 1/2 x minus 1. Or you can pick any of the other 3 points. It doesn't matter. I'll take 4 different answers there. But the awesome thing is I have to use this guy as a middleman to get to slope-intercept form. So I'm going to distribute my 1/2 to get rid of the parentheses. Please don't write -1. You have to multiply the 1 by the 1/2. I'm going to bring everything else down. And then I need to move this 2 adder to the other side, which is going to become a 2 subtractor. Right? And that's going to give us y equals 1/2 x. Again, use your calculator if you need to here. Oh, sorry. That's going to end up giving us -5/2. And that is my y equals mx plus b form. If you want to write that 5/2 as 2.5, you're totally welcome to, because it's a nice, pretty finite decimal. I would take that also. Okay, I'm going to draw a little line over here so I have space to work. So now I'm going to take my point slope form. I'm going to carry it over here if that's cool with everybody. And now I'm going to put it into standard form. I feel like a broken record. Like we've done this a dozen times already on this review, right? So standard form, we have to get all of our x's to the left to join our y's so that it's an ax plus by. So we need to move this plus 1/2 x or positive 1/2 x, but we just can't move it over. If he hops over an equal sign, he has to change sign. So he becomes a minus or negative 1/2 x on the other side, plus y equals, and that is a negative 5/2. I'm kind of covering up my negative a little bit there, so be careful. And sadly, we have a problem because not only do we have a negative starter, we also have two dividers. So I'm going to multiply everybody by -2 to take care of both of those problems at once. So this -2 cancels out with this -2. If you don't know that, then please use your calculator. Just type in -1/2 times -2, and you're going to get positive 1x or just 1x. And then -2 times y is -2y. And then again, you can type this in your calculator if you want to, or just again, cancel out the -2's, right? This -2 is going to cancel out with this -2, and that's just going to leave you with 5. Or just use your calculator and call it a day. If you're not good with fractions, no big deal. You get to use a calculator, and that's our standard form. X minus 2y equals 5. All right, here we go. Going backwards. We give you the graph. You give us the equations. All right, so write the equation below in slope-intercept form. Okay, well, my intercept, let me pick a different color. My intercept is 3, right? So y equals, I know it's going to be a plus 3 at the back, and I need to go find the slope. Well, it looks like I'm going up 1 and over 3. Right, to get to my next major point on a corner there. So that means our slope is 1/3. So 1/3 x plus 3. Let me scoot you that over. There we go. Point slope form, guys, it's just like the table. It's no different, right? Pick a point. I don't care which one. I'm just going to pick this one, not for any particular reason. So I'm going to pick the point 3, 4, and I've already found my slope is 1/3. So now I have a point. Now I have a slope. So just write that out in point slope form. Y minus 4 equals 1/3 x minus 3. That looks weird. Let me fix that -3. There we go. All right, in standard form, I'm certainly not going to get that from a graph ever. Right, so standard form, I need to take my y equals mx plus b form. Oh, I did not mean to do that. Hold on. That looks weird. There we go. Copy, paste. Okay, so I'm going to take my y equals mx plus b form. Oh my goodness, we've done this so many times. So again, I need to take my positive 1/3 x. I need to move it over to join my y's. But the only way to move a term to the other side is by taking the opposite sign. He's an adder on the right, so he becomes a subtractor on the left. Bring down everything else. And then unfortunately, just like the last problem, I have a negative and I have a divider. So I need to multiply everybody by -3 to get rid of those two things that are breaking the rules here. So this -3 cancels out with this -3. Again, if you don't understand that, just type in your calculator. You get 1x minus 3y, and of course, -9. And that is our standard form. X minus 3y equals -9. All right. Another story problem. They just want you to do the equation. Thank goodness. It says a baker sells cupcakes and cakes. Cupcakes are $3 each and cakes are $30 each. The baker wants to make $405 total by the end of the day. We talked about this in class, even though I know it tells you what form to use, but that's not always going to be the case. Remember, they're giving you the total amount of money. And we talked about this in class. Anytime you're given a total, like the actual final total, remember that always equals standard form. Right? Now, I know they're telling you in the problem, they're reminding you to use standard form, but we should have known that anyway. All right, so $3 per cupcake. So I'm just going to make cupcakes X plus $30 per cake. So I'm just going to make cakes Y. And you add that all together and you should get 405 total. I am going to go ahead and just help tell my reader what cupcakes and what the X and Y stand for. So X is number of cupcakes. You don't have to do this necessarily, but I don't want my reader to get confused. And then Y is number of cakes. They both start with C, so I obviously don't want to say 3C plus 30C because then it looks like the same term. So anyway, there you go. All right, direct variation. Sorry, how much more do we have? Oh my goodness. Okay, here we go. We can do it. All right, suppose Y varies directly with X. Okay, well remember, as soon as I see the phrase varies directly, that means I must be looking at a graph that goes through 0, 0. And then they're also going to give me another point that lies on the line when they tell me that when X is 8, Y is 12. So now I have 2 points that lie on the line, so I should be able to calculate this slope. And again, there's definitely shortcuts here, so if you find them, then that's great. So Y minus Y divided by X minus X. So we end up getting 12 over 8, which should make perfect sense. But when I reduce that, we're going to get, sorry about that. I didn't mean to write that. Sorry, when we reduce that, we're going to get 3 halves. All right, now that's not your final answer. That's just slope. So remember, direct variation equations are y equals mx or y equals kx, if you will. So you just need to plug in your slope of 3 halves and actually write the equation. Don't just stop at slope. You need to go all the way and actually write the y equals mx plus b. If you want to throw a plus 0 at the end, have at it, right? Because you know it's passing through the origin. Now we're going to take this equation right here and we're going to manipulate it. And if I can give you the x, you can give me the y. If I give you the y, you give me the x. Okay, so here we go. I'm going to copy and paste this. All right, so it says when x is 6. All right, well, that means I'm going to go to my equation and I'm going to rewrite it and I'm going to put a 6 in place of the x. So that's going to give me y equals 3 halves times 6, which gives me y equals 9. So when x is 6, y is 9. All right, and then I should be able to, I should be able to do that exact same thing again, just with the opposite variable. Oh, I knew I was going to do that. There you go. All right, but now it's giving me the opposite. Now it's giving me the y. So I'm going to take the y equals 18. I'm not going to plug it in for x because it's not x, it's y. So go to your equation, rewrite your equation, but put an 18 in place of the y. Now it's always more work to solve for x than y because you actually have to solve the equation, but no big deal. We want to get rid of this 3 halves multiplier. So he's going to become a 3 halves divider when we move him to the other side. And if you don't know what that is, then just use your calculator, right? So dividing by 3 halves, let's see, that's going to give us 12 for x. And again, you can just use your calculator for that if you need to. Okie dokie. All right. Yep. All right, here we go. Suppose the number of students who pass their test varies directly. All right. So again, I'm going to go ahead and write 0, 0 down here if that's cool with everybody. And it says that P varies directly with R. Please remember that it's Y varies, God, it's really sloppy, sorry. Y varies directly with X. So please remember, Y is always mentioned first, right? Because Y depends on X. Y is a function of X, right? So when you see phrases like this, the Y is always first. So when it says P varies directly with R, that means R is your X variable and P is your Y variable. I know that's a lot of letters. That's kind of confusing. Sorry about that. Okay, well then they give us another point up here. It says for every 5 reviews, R is X. So I'm going to put the 5 here. For every 5 reviews turned in, 3 students pass. Okay, so passing is Y's, so 5, 3. All right, so you just have to know how to interpret the verbiage there. All right, well, let's go find our slope. All right, so our slope, 3 minus 0 over 5 minus 0, which is 3/5. That's it. That's our slope. But you're not done because we haven't written the actual equation, right? The equation isn't 3/5. The equation is Y equals 3/5 X. Yay. Right, so that is our direct variation equation. So now we should be able to manipulate it given whatever pieces of information we have. Oh, you know what? Sorry, I'm going to scoochie this over here. Okay, I'm going to write or. All right, I should have used P's and R's because that's what they want me to do. So I'm going to write, oh my God, I just did it again. I'm just so used to writing Y's. But my Y's are actually P's, the number of kids that pass, right? And my X's are R's. So I'm going to write it as P equals 3/5 R. And that actually makes it a little easier when I'm given values to plug in because I know what P and R stand for, much easier than I know what X and Y stand for. Okay, so again, I'll take it either way, but this might help us a little bit more. So I'm going to copy that and paste it down here like I've been doing. All right, so we're answering the question. Find the number of students who will pass their test if 20 students turn their reviews in. Right? So the 20 is the reviews. So we're going to take this 20 and we're going to plug it in for reviews. Right? So that's going to give us P equals 3/5 times 20, which is going to give us P equals, and you can just type that in your calculator if you don't know what that is, that's going to give us 12. So 12 kids will pass if 20 students turn in their reviews, according to this equation. All right, let me copy and paste this guy again. Paste it down here. All right. Now it says, oh, you know what? I'm going to scoochie him over here. All right, so now it says if 18 people pass. Okay, well now that's giving me the value for P because P is people who pass. So now when I rewrite that equation, I'm going to put the 18 in for P, and now I'm going to solve for the R. Again, it's always harder to solve for the X than the Y because I need to get rid of this 3/5 multiplier, and he's going to become a 3/5 divider over here. Again, use your calculator. It's there for a reason, right? So let's see, 5 thirds, that's going to be what, 30? So if 18 kids passed, that means 30 kids turned in their review because 3/5 of 30 is 18. All right, we're just working the problem in reverse. All right. Draw scatter plots that represent positive, negative, and no correlation. All right, I'm literally going to draw this super duper fast, right? So positive correlation, right, means that your dots are scattered, but still following a positive linear trend, right? So this is positive correlation. Negative correlation, this is directly off of our notes, right? This is all in your notes. Negative correlation is if you have dots, it's still a scatter plot, but your eye naturally follows a negatively sloped line. That's negative correlation. And then of course we have no correlation, right? And that literally just means that your dots are all over the place, right? My eyeball does not go in an increasing or decreasing manner, right? No matter what. Okay. All right, so use your calculator. I would prefer that you use Desmos, right? Because it's so much easier on Desmos than it is on your calculator. Plus, everybody has access to Desmos at home, and you don't all have access to graphing calculators at home, so it's just easier. All right. Sorry, I'm pulling this up so I can get in here with the, which one are we doing? Okay, sorry, I just want to make sure everything's matching with what I'm doing. Okay, so remember, you're going to go into Desmos, you're going to hit the little plus sign, right? And you're going to add a table, right? That's what everybody does first, is you go add a table. And so a little table is going to pop up in your Desmos, and you need to enter all these data points, sorry. And you need to be very accurate with it, right? That's a lot of decimals. That's a lot of numbers. You need to make sure that you're super careful, right? Then you hop to your next line and you instruct Desmos to run a linear regression. So you type in y sub 1 is approximately mx sub 1 plus b. These are your instructions to tell Desmos to run a linear regression and to find your line of best fit. So please pause the video and go do this, because if you don't practice it on your own and make sure you get the right numbers, then the chances of you getting it correct on the test are pretty slim. And I'm not going to help you figure out how to do this on the test if you don't know how to do it by yourself. So I'm just going to go ahead, again, pause the video and go do this yourself. I'm going to go ahead, though, and write the equation that Desmos should be getting. Remember, we're going to round our slope and y-intercept to 2 decimal places. So negative 32.48x plus 1079.90. You don't have to write the 0 if you don't want to. Then it wants you to find the correlation coefficient, right? And if you do that, you're going to get negative, I'm sorry, I didn't put my negative. Negative 0.8864. And that is your R. Please make sure you write R equals, right? Because no naked numbers, right? And then the type of correlation, this would be a strong negative correlation, which makes sense because you can clearly see in your Desmos that it is, the dots are following a negative linear trend. Okay. All right. Talking about association versus causation. All right. So the longer you run on a treadmill, the more calories you burn. Okay. Well, if you are in fact running the whole time, then yeah, the more you run, the more calories you're going to burn. Right. So this is causation. It does say justify your reasoning. So please make sure you do that. Right. And so, for example, my justification for causation, you might write something like, as one increases, the other one does too, or something to that effect, like one directly causes the other, right? So something like that. The amount of time you spent studying, the better your quiz grade or test grade. We talked about this in class. That was one we already discussed. Right? That is definitely an association. There is a relationship, right? Typically, right? If you were to collect data from, hundreds of thousands of students, on average, you would see better test grades for more studying, but that's not always the case, right? That's not a perfect cause and effect relationship. So that's why we call it an association. Let's see, the amount of police in a city and the number of animals in a city. Well, police are not in charge of animals, so I'm going to say neither here, right? If you talked about animal control officers, or I'm trying to think of what we call animal control, just animal control employees, then you might say an association, right? But in this case, it's neither, because that's not the police job. All right, the last one, draw a trend line on the scatter plot below and then use it to answer the questions. Okay, so this is very much a star question, right? And so they're wanting you to just do all the estimation on your own, okay? Now, the one thing that should jump out at you about this graph is that there is a break right here, right? So do you notice they're going by twos along the x-axis? Oops, 90, 94. They're going by twos, but they started at 80. So that's what this little zigzaggy line means right here. They didn't want to start at 0 and go 2, 4, 6, 8, 10 and have this huge vacant section of graph. So they put a break in it. So just keep that in mind. All right, so I'm just going to guesstimate what the line of best fit would be here. So we want the line that kind of has the same number of points above as below. So just eyeball it, right? It doesn't have to be perfect. So I'm just going to draw something like this-ish. All right, maybe like there. I don't know. The questions are going to be vague enough that you don't have to have a perfect line. So don't worry too much about it. You do not need to try to figure out what these points are and put them into Desmos. That is totally not expected of you. If you want to, then you can try, but it's not necessary. All right, so it says if the average daily temperature reaches 100, what is a reasonable number of visitors? Oh, God. Normally these would be multiple choice, you guys. So, again, crazy. I don't like this question. I think they took the multiple choice off on the review. Okay, so I'm going to kind of kick out here. Let's see. This is 96, which means this is 98, which means 100 would be just slightly off the graph right here. Yes? So I'm going to take that 100 and I'm going to kind of follow it up to my line of best fit. Oh my gosh. Why would they do this to us, you all? Like I said, normally this would be a multiple choice question. And we would want to follow that over. So we went up to the line and now we want to follow it over to figure out what y value that would be. Well, this is so not the best question ever. Okay, so I'm going to extend my y-axis, and it looks like our y-axis is going by 75s. Oops. Oh, no. There we go. So let's see. This would be 675, right? And I'm going to try to keep it as consistently spaced as I can. So that would be 750, right? And then this would be, what, 825? And then it looks like my little top guy here is going to be 900. So according to my graph, right, and my line of best fit, then a reasonable number of visitors would be 900 visitors. Now, is it okay if you get like 850 visitors or whatnot? Yes, right? You can, or 840, right? We don't all have to get the same answer here. If this was an actual question, like on a STAR test, it would have multiple choice. And your multiple choice answers would be so clearly obvious which one was the correct one. For example, it might have like 900 right here, which is obviously the answer. According to my line, you could have gotten a different answer. That'd be totally cool. And then the other answers would be like 600, 250, and 500. Well, clearly these are all so low that I know that my graph is has to be something higher than 675. So I would just pick whatever answer was higher than 675 because it clearly goes off my graph. Does that make sense? Right? So if it was multiple choice, it would be glaringly obvious which answer choice it was. All right. And then it says, if the number of visitors reaches 625, what is a possible temperature? Okay, well, we're just going to do the exact opposite. So 625, right? We're going to kind of eyeball where 625 is. So that's about here-ish, right? So I'm going to follow that over to my line of best fit. Oh, it's a little crooked. Hold on. Let me try that one more time. All right. And then I'm going to drop to the temperature at that value and then just going to eyeball what that is, right? So for me, that's really close to the 94 degree mark. So I'm going to put 94 degrees. Again, if you don't get 94 degrees, sorry, I'm going to color code this. What did I say? 900. Oh, I lost my little zero. Hold on. Sorry, guys. Oh, never mind. I used the same color. I probably shouldn't have done that. All right. And again, if you get a different degree, don't freak out about that, right? If this was a multiple choice, let me just show you this one more time. If this was a multiple choice question, right, then the answer would be glaringly obvious, right? It might have like 94 degrees as an option, which would be our winner, right? But it would have other temperatures like 80 degrees, 120 degrees, and then like 50 degrees or something. Like nothing even around, remotely around where you would, the correct temperature if you drew your line of best fit even close to accurate, right? So anyway, that's kind of what that would look like on a STAR test. Okay, so maybe on your actual test there would be a multiple choice situation happening here. If not, then of course I would accept a variety of answers, like within like a plus or minus 30 range or something like that, depending on the problem. Okay, so I don't expect perfection there. All right. Oh my gosh, I think we actually finally are done with this review. All right, guys, I hope that helped you out. I hope you study hard, and I hope you do really awesome on your Unit 3 test. All right, see you tomorrow.